Today we will study the very nice portion of derivative chapter, which is a calculus portion of integration derivative, like you know already. This is the implicit function. These are the outlines today. Discussion implicit function and how to find derivative of implicit function and the related questions. So before starting this, what is implicit function and more about the function, you know already what is derivative, how derivative applied to our general science in engineering problems or a differential equation to solve the integration of a particular question. So today we will discuss the implicit function and what is the meaning of implicit function. Already know to define a function, variables required. There are two types of general variable. One is dependent variable, other one is a independent variable. Dependent variable means suppose y is equal to, I write x square, y is dependent, x is independent, or y is equal to sin x, y is dependent, x is also independent. Similarly, when in a function both dependent variable and independent variable are in a combined form, that means y and x are in a combined form so that we cannot separate them easily. It is called implicit function. So let us discuss. This is the implicit function, meaning if the variable x and y are so connected, are so related, so that the relation of the form fxy, function of both x and y, is equal to 0, and it is not possible or convenient so easy to differentiate or to express y as a function of x, then y is said to be the implicit function of x. For example, x y square plus x square y plus 1 is equal to 0, and in this expression we mark here x and y cannot never be separated. Similarly, x square cot y plus y is equal to y square cot x. We can mix them, but x in the form of y or y in the form of x, never possible. Similarly, another one I write x is equal to y, y is equal to x. Similarly, this is the exponential form, x is the base, y is the power here or exponent. This is similarly cannot be x and y separated. This is called combination of both independent variable and dependent variable. And these are the some examples of implicit functions. And to find derivative of such functions means either dy by dx or dx by dy. In the notation dy by dx, I write here dy by dx, y is dependent, x is independent. And the reverse just dx by dy, x is dependent, y is independent. And how to, in today's discussion, I will discuss how to find dy by dx. These are the following steps I marked right here. Step 1, in a given function which is particularly implicit function, means both independent variable and dependent variable or y and x are combined form and cannot be separated so easily. These are the steps to find derivative. Already you know in the previous classes the chain rule, logarithm. When logarithm use, take derivative of both sides and simplify using standard rule. Standard rule means maybe addition, maybe subtraction, multiplication, division. Wherever required, it is maybe chain rule, inverse function, and so on. And step 2 is keep all dy by dx containing terms in LHS and transfer other to RHS. Means after taking derivative of the given expression and simplifying by taking the different formulas like chain rule, key addition, subtraction, and so on, then keep all dy by dx containing term or singly it may be dy by dx in LHS and transfer other to RHS. Step 3, take common dy by dx from LHS and divide the coefficient of dy by dx. Means coefficient means after taking common dy by dx from LHS, divide the coefficient, that means what multiplied with dy by dx with RHS, which is the required solution or required value of the derivative dy by dx. And in some cases, we will differentiate the function of a variable y with respect to variable of x here. Let us discuss the same in a given particular question. For example, already know suppose derivative of sin x is cos x, derivative of x square is 2x. Now mark here derivative of sin x with respect to same variable x. Is answer is cos x. Derivative of x square with respect to x is answer is 2x. This directly comes from formula derivative of x to the power n, derivative of trigonometric function tan sec and cosec so on. But whenever the function is a other variable means y, but with respect to x, the process is different. Now see here. Sin other is a variable y. So first by applying chain rule, there are two functions means sin trigonometry, y is other variable. So sin derivative is cos. First of all, sin derivative is cos. Then y derivative is dy by dx. This is by chain rule. So whenever the function contains a variable, other variable y, but our derivative is with respect to x. So dy by dx is just like its partner, always present dy by dx. Originally sin y derivative cos x, cos y, and multiplied by dy by dx. Similarly, derivative of yq is equal to, similarly yq derivative means like x cube derivative 3x square. Here yq derivative is 3y square, but since y present here, it is multiplied by dy by dx as per the previous discussion. Similarly, log y derivative. Now see here log y, not log x. Already you know derivative of log x is 1 by x. Similarly, derivative of log y, but with respect to x here. If with respect to y, simply answer is 1 by y. So derivative of log y is nothing but 1 by y into dy by dx. Similarly, derivative of e to the power y into dy by dx, or derivative of sin inverse y, like your sin inverse x derivative 1 by square root of 1 minus x square. Similarly, derivative of sin inverse y with respect to x. First of all, sin inverse y derivative original answer is 1 by minus 1 minus y square root over into, since y present with respect to x, its partner is dy by dx. So very clear, by chain rule you take a when derivative of the function given with x variable with respect to x, it is only the answer is the same variable. But when the function is other variable with respect to other variable, the derivative part dy by dx or maybe dx by dy always present. Let us discuss the same in the some related questions. Suppose I write a example here, find dy by dx when y cube plus 3x square minus 2x is equal to 10. Now see the LHS of our expression clearly, it is a function of both x and y, both x and y present. We cannot separate x and y explicitly. And the solution, the previous steps, first of all, since it is algebraic expression, not required to so apply any algebraic logarithm or exponential relation. Directly take a differentiating both sides with respect to x, that means d by dx of the LHS. Similarly, d by dx or derivative of right side 10. Already know derivative of constant is 0. I write here 0. And when you apply the same method, y, see here y cube present or y related term present, always a dy by dx must present. So derivative of y cube is 3y square and multiplied by dy by dx. Next term is 3x square y. 3 is a constant as per relation rule. 3 take outside, the rest part is x square y. X square y means x square multiplied by y. So here rule, multiplication rule required. So first of all, let me see derivative of u into b means first derivative into second plus second derivative into first. So x square derivative clearly 2x into y plus x square into y derivative simply dy by dx. But keep in a bracket. Bracket is important. Derivative of minus 2x. 2 is constant, minus 2x derivative 1. Not required to write. Next implies 3y square dy by dx, multiply the bracket with the 3. 6xy plus 3x square into dy by dx minus 2 0. And last step is keep all dy by dx term LHS and transfer other to RHS. That means 3y square dy by dx along with 3x square dy by dx keep LHS, transfer 2 means minus 2 goes to right side, plus 2 minus 6xy. Then the coefficient of dy by dx is nothing but 3x square y square. It will be divided with RHS means 2 minus 6xy. Our final answer is taking 2 common from numerator, 2 into 1 minus 3xy, or 3 from denominator, 3 into x square plus y square. Clear? So particular mark here, the expression given, it is a combination of both x and y. Maybe y dependent, x independent, maybe x dependent, y independent. Suppose a question given, find dx by dy, we differentiate both sides with respect to y here, and accordingly proceed and get the answer. Let us see another question. Suppose find dy by dx when a question given like this, y to the power x is equal to x to the power y. Now here see, it is an expression both x and y present, but what is the difference in compared to last question? The last question given just algebraic form. This is also algebraic, but given in exponent form, y power x, here x power y. So unless we write in a expression of a previous question like, we cannot take a derivative of both sides. And already you know from logarithm, there is a formula behind log of m to the power n is equal to n log m. And this is required here. Either m and n are both numbers, maybe variables, maybe dependent, maybe independent, so on. For example, suppose log of x square is nothing but 2 comes to beginning 2 log x. So clearly this is an expression of algebraic expression. See here power given, here algebraic expression. So similarly here answer 1, first write x to the power y given y to the power x. So implies take logarithm of both sides means log x to the power y is equal to log y to the power x. Clear? So as per the right side formula, what happens here? Y log x is equal to x log y. Clear? So now it is expression is this is a expression not purely it is algebraic form. Then we proceed as our steps of finding derivative in the implicit function. Implies take derivative of both sides, derivative of y log x is equal to derivative means d by dx of x log y. And since see both sides given in the product form, y multiplied with log x or x multiplied with log y, we apply here multiplication rule or product rule, that is a derivative of u into v. Derivative of y into log x means first y derivative, which is nothing but dy by dx into v log x plus y means u keep it fixed, and log x nothing but derivative 1 by x. And similarly right side one, derivative of x means 1 into second keep fixed plus x into derivative of log y is nothing but since here y present means attached with dy by dx. So 1 by y into dy by dx. So this completes your application of the UV or product rule. Next keep all dy by dx term LHS, transfer other to RHS. So this is dy by dx term, this is also dy by dx term, take LHS, and direct you can take common also, take dy by dx common, which is nothing but log x minus, and the right side one is x by y. Clear? Is equal to the right side one is 1 into log y, same as only log y, and LHS y into 1 by x, y by x, or it goes to right side log y minus y by x and keep bracket. And the final answer is implies dy by dx RHS divided with LHS means log y minus y by x whole divided by log x minus x by y. Clear? This is the final answer. We can write in the simplified form also. Take LCM x log y minus y divided by x whole divided by y log x minus x by y. Our final answer is equal to y by x whole into x log y minus y divided by y log x minus x. So this is your answer. So clear? This is a related to logarithm based and implicit function. Consider another example. Let us. Similarly, find derivative of dy by to find dy by dx where suppose given ln x square plus y square root over is equal to tan inverse y by x. This is a combination of inverse trigonometry and logarithm. And see here, both sides given xy, also RHS given xy. So first of all, no logarithm required here because neither side given in exponential form. So first take a derivative of both sides. Derivative of ln x square plus y square root over with a bracket. Bracket is important always. Tan inverse y by x with a bracket. And simplify. And clearly it is a function of three components, means one is a logarithm ln logarithm, another is a square root function, other is algebraic function. So three derivatives. This is by chain rule. RHS also inverse function. This is by division. So logarithm derivative ln x derivative 1 by x. So first of all by chain rule 1 by x square plus y square root over. So logarithm cancel. So next come to square root. Square root means root 2x derivative already you know, 1 by 2 root x. Similarly 1 by 2 within root over x square plus y square root over. So root over cancel. So next one is x square plus y square, algebra addition. So but it is a within bracket. Unless you give bracket here, it will be starts wrong. So x square derivative simply 2x. Again now see y will come. Y square derivative is 2y, but attached with dy by dx. So LHS finished. Next come to derivative of RHS1 tan inverse y by x. Derivative of tan inverse x is 1 by 1 plus x square. Similarly 1 by 1 plus x in place of x here y by x. So y square by x square into what is derivative of y by x? It is by division formula, u by v formula, again with a bracket. First denominator square means x square, numerator derivative y derivative dy by dx, derivative u into v minus y into x derivative u r. Clear? So let us first simplify the LHS RHS again. See implies 1 by x square y square root over same term here. It will mean 2 into x square plus y square, because root x and root x is simply x, and take 2 common here, because simplification means how to reduce the expression to lowest form is equal to RHS 1 by something given here, take LCM and so on. Simplification x square divided by x square plus y square, and it is nothing but x into dy by dx minus y whole divided by x square. Now see LHS a big expression, RHS also similarly, and how to simplify. Now see there are similar terms, both RHS also x square here x square cancel, both side denominator also x square y square cancel, Here 2 cancel, 2 cancel. So our question, it was very small, answer is a little big. But again reduce to a lowest form. Again rewrite the remaining x plus y dy by dx. And the right side is nothing but x into dy by dx minus y. Clear? Implies. So next step is keep dy by dx LHS and other two RHS. So take a dy by dx common means I just reverse take a first x minus y. This one attach, I take a RHS and this one take LHS means x plus y. Implies the last answer one is part is x plus y dy by dx is equal to x plus y by x minus y. This is nothing but our answer. Clear? So similarly we can take other examples related to our question. Similarly, I can take another example. Suppose I take a x square plus y square root over is equal to x to the power y, or y to the power x is equal to x to the power sin x. These are also related to logarithm come answer. Clear? So perhaps this is the very important portion of derivative implicit function. In the next classes we will proceed some other chapters. So thank you all.